In this lesson, we're going to understand how to identify anomaly detection using Euclidean distance. So this is also a distance-based approach wherein we measure the distance from one point to another. Say, for example, from point A going to point B, but only that it has a different nature and characteristics. So if you could still remember, in our last lesson, we talked about Mahalanobis distance, wherein we said that when our data set has different dimensions, and these dimensions are incommensurable, and they have different mutual correlations, then we're going to use Mahalanobis distance. So we said that in Mahalanobis distance, we always take note of a diagonal matrix. And so when the covariance matrix is diagonal, then we said that Mahalanobis distance is more applicable, and we showed a certain formula on how to do that. Why do I explain that? I explain that it's because it's really very important for us to be able to understand the pattern from Mahalanobis distance to Euclidean distance. So don't forget, it is diagonal, then we're going to use Mahalanobis distance. So when our covariance matrix, which is represented by S, is an identity matrix, then what we will do is that we're going to reduce our distance to a Euclidean distance. So what is an identity matrix? I think as far as this lesson is concerned, I think we don't need to do we don't need to explain more about that. So I have lessons in machine learning essentials, and you can have the different lessons on the different foundational understanding of machine learning. Going back to this one, what is this Euclidean distance? So Euclidean distance is actually very simple because we only use the computation of Pythagorean theorem. I think this is very much familiar to you, Pythagorean theorem. I believe this formula is very familiar to you. So here we measure the distance, d is the distance, from point P going to point Q. Say, for example, we have this one, point P, and this is the point Q. So how do we do that? So we get the square root of the summation of the squared value or squared difference between the P1 and the Q, or Pi and or minus the Qi, and then we square that. So we do this one in all of the points. Of course, in anomaly detection, we have a lot of points, okay? So we don't just consider only 2 points, but there are actually millions, especially when we are talking about big data, then we need to take note of millions of data points. So what do we do then before we do this one? So we always have to bear in mind that I'm going to flip this one. Let's just use this part. So before we go into this, the most important thing that we need to do is we need to normalize the data points. Normalized. And normalization is very important so that the values of the points would be along the dimensions. Normalization is very important so that each dimension has value between -1 and +1. Okay, so these are the values that each point should be. So that's how we do it for the Euclidean distance, and this is very important so that we would be able to identify whether or not a certain point is anomalous or not. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.